Hey, Dhaval, are you from NVIDIA?
Yes, this is Dhaval from NVIDIA.
Hey, I remember you. I
Hey,
used to.
Jagannath.
Do you
Uh-huh.
remember me?
No, I can't. Sorry, can you help me remember?
I used to work with. I actually used to work with another manager called Javin Ferreira. I joined as an intern in 2012.
Okay.
You were the Windows RM manager at the time.
Okay. Okay. Yes,
Yeah.
that's a long time ago.
What are you working on now?
Ah, a
Are you in
lot
RM?
has evolved. No, I don't work on RM.
Oh,
Um,
okay.
I work on hardware firmware security
Oh,
most
okay.
of the time.
Okay, got it. Nice to meet you.
Yeah, same here.
Hi, folks.
Hey everybody, how you doing today?
Good. How about you?
Oh, I can't complain.
Good.
Overwhelmed, but I can't complain.
There's no time to complain.
Yeah, exactly. I see Dewal is here. Excellent. Dewal, looking forward to your presentation. Thank you for volunteering to discuss some very interesting topics.
And for
Sure.
getting your slides out ahead of time.
Thank you for the
You're gonna-
opportunity.
you're setting a high bar for those who follow you.
I see. I didn't know the
I,
rules of the game.
I, I had dreamt of finding time to bring some of my CORIM questions
Uh-huh.
and tales of woe this fall, and I'm happy to see that you're bringing your own flavor of that. Um, I'm the co-chair for today's meeting, so just FYI, I'm going to wait another couple minutes before we officially kick it off because usually
Sure.
we have people straggling in for the first 3-4 minutes. All right, let's get this going. I suspect it's going to be lots of fun conversations and questions about Dual's topic today. Before we jump in, does anybody have anything short and urgent, like an announcement or anything they wanted to share with the group before we turn it over to Dual to discuss some of his experience with COREM for the next hour or so?
Yeah, this is Gary here. I just wanted to reconfirm we're on the hook to present the OCP EAT entity attestation token profile to the group at the next meeting. Oh,
You are officially, or that topic's officially slated for 2 weeks out from now. So
okay,
you own it, and unless you choose to give it up, in my mind, that's your time slot.
okay, thanks.
Thank you, Gary. Okay, well, with that, let's get it going. So Dual from NVIDIA, I believe, has volunteered to discuss some topics around CORIM in today's discussion. I scanned the deck. I've had some similar questions in areas myself, in particular, how to deal with revocation. So I'm looking forward to today's discussion. With that, Dwal, I'll turn it over to you.
Thank you very much. Can somebody confirm whether my slide deck is visible?
Yeah, I see it.
Looks
Thank you
good.
very much. So here's the agenda for today. There are actually three broad topics, the first three with bold on this slide. First one is modeling a few scenarios. I'll talk about those scenarios in a moment. And then I would like to understand whether the quorum is expected to handle some of these scenarios, in particular the one that says challenge, and then ending with finally with understanding of whether the RFC is intended to capture some of these scenarios, or would it be helpful to capture some of these scenarios. Subsequently, getting into the RFC evolution. RFC has evolved from various drafts. People have already started using it. What are the implications of those? And lastly, quorum revocation. The last item shown on this agenda is primarily a collection of all the questions and topics or the key items. So to start with, the four scenarios that I would like to discuss as a part of the first topic, I'll just present the scenarios first, and then we can talk about the questions that I have. The four scenarios, while there are many scenarios, I thought four would be useful and interesting enough for one meeting today. So first is that of a device that has four mutually exclusive modes. Mutually exclusive means they wouldn't be simultaneously active at a given point in time, but the device may transition from one mode to the next, even without an intervening power cycle. So for example, a device could be in confidential compute mode. I put three other examples in bracket in the slide. It could be in a non-confidential compute mode, but it could be, let's say, a different performance power profile. It could even be a pre-boot mode, which is the subject of another slide in this presentation. But the key with respect to these non-coexistent modes is that the set of possible measurements, or the M key equivalent, would be the same for all modes. Only the reference values differ between these modes. The second scenario is that where the device, imagine the device is in a particular mode, but the list of claims or the evidences that it's reporting is different for device user versus owner. A device user, think of it as a device user as a tenant, owner as a CSP. And the reason why they may be different, I'll cover that in another slide. For now, I'm just trying to give a high-level overview of the possible scenarios so that when answering questions or discussing, we can consider all the scenarios in our head at the same time. The third is that of a pre-boot state, which is, imagine a device booting up and then it has loaded its firmware. It's mostly ready to go, but not entirely. Sometimes there's a device driver that comes into the picture, and the device driver may alter the state of the device, and in a meaningful way that is relevant to security. And lastly, I think this is a scenario that is somewhat covered in RFC, or maybe it's fully covered and I could not pick up enough of it, is that of a situation where you have a root of trust for storage. Think of PCRs if you wish, but the device is a journey. It may be in a specific state, but it may have gone through a journey to reach that particular state. So again, think of a specific mode, let's say it's confidential compute, but the device, let's say, had a section of it which was loaded, unloaded many times, or a section of device state which was loaded, unloaded many times. So it may be in a specific state, but it went through many intermediate hops before reaching that state. Another example could be, let's say, the device loaded firmware 1, went to firmware 2, back to firmware 1. Ultimate state is firmware 1, but it had a journey. And so if you look at any relevant PCR into which all the relevant measurements were extended, then the final value would not match what one would normally think are associated with state one. Now let's get deeper into the questions associated with each of the scenarios that I want to discuss with this forum.
So,
Again,
pardon me for interrupting, Dual, just a little bit of
Mhm.
mechanics here. I see one hand raised by Osama. And before we deal with that, how do you want to take questions? You want to do it on the fly or encourage at the end, or?
Yeah, if there are questions on what I have on the slide, let's take it before I move it away. But if you have questions on material that I have not shown yet, then perhaps wait until the end.
Okay, great. So there's one hand raised, Osama.
Yeah, thanks. Yes, it's related to what you are presenting here, this specific slide. I'm trying to get an overall idea of the 4 modes that you have in number 1. Like, to me, it would be either CC mode or a non-CC mode. So I don't understand fully your distinction, like kind of that you are trying to make in these, and you explicitly say that these are mutually exclusive. To me, it would be, so the sketch I have in my mind would be CC, non-CC, and inside non-CC, you have perhaps some distinction between optimized and maximum performance. But I am struggling a lot to put pre-boot into some category, because in any case, it will be either CC or non-CC. What does it mean to have pre-boot as a 4th mutually exclusive mode? That's not clear to me.
Sure. So the device may operate in different modes, which are useful for different operations. So let's take a step back and walk through the journey of the device. When the device boots, let's say it boots firmware. Now it has booted firmware, and now the infrastructure owner or the CSP wants to run attestation.
Just to be clear, so when you say device firmware, so do you mean the system firmware or the virtual machine firmware? So at which level of abstraction we are talking about?
When I say device firmware, I'm talking about the firmware that ships along with the device. So imagine that the device has an SPI flash or eUMC or something that's tightly coupled with the device, with the ASIC associated with the device. So when I say pre-boot, the best you can do in terms of setting up the device state is you have consumed the entirety of the firmware that was resident in the non-volatile memory that was tightly coupled with the device. There's nothing more the device could possibly do in terms of furthermore booting up.
Okay, so we are talking about strictly some small devices, like, so we are not talking about CPUs that where we have system firmware and then some VM will load and so on. So it's kind of the, so you're kind of thinking about the other devices, small devices, right? So that's the interpretation. Is that correct?
Yeah, not necessarily small. It is a general description. Yes, you are right that in case of CPUs, typically you would not think of this state because the CPU is the main entity that comes up and drives the entire platform. However, think of all the other devices, all the accelerator devices. GPU itself is an example. GPU is not small in terms of at least the size, if you wish, not even in the terms of the quantity of code that executes on the GPU, but it does have a pre-boot state. And the subsequent state is built upon what driver brings in. And the driver is part of the operating system, which is part of, let's say, SSD. It's not part of the NVM that's associated or tightly coupled with GPU. Even for the CPU, the VM comes into the picture only when the SSD, in my example, comes into the picture. Right? If there was no SSD, or let's say you booted into the BIOS screen of your computer, then you are really just looking at, let's say, typically what is contained in the SPI flash associated with the CPU. It may be a different matter that the CPUs typically don't ship with SPI flash. They go onto a motherboard, which has its own SPI flash. So it's not that tightly coupled. But for all the other accelerator devices, you have these standalone cards, right? Let's say the PCI card in case of a GPU or a DPU or any NIC, for example. Is that clear?
Kind of. Maybe you can quickly answer one doubt in my mind from CPU perspective. You said that it also applies to CPU. Maybe you can clarify me from because I tend to think more about CPUs and so on.
Okay.
Rather than
Okay, no
GPU,
problem.
I have no experience. So maybe
Okay.
you can tell from your perspective that
Mhm.
firmware will be the system firmware or the virtual machine firmware. I guess
It would
it's the
be, yeah, so for a typical CPU, not going all the way to virtualization, let's talk from the time we touch the power button on the motherboard. So the CPU will boot up typically, say some initial CPU firmware if applicable, and then it will execute UEFI. If you stop at that UEFI stage, that would be the pre-boot stage for the CPU.
Okay, perfect. Thanks very much.
All right, moving further. So to the first non-coexistent, first set of questions related to the non-coexistent device modes. And again, I'll pose the questions. We can answer all of these questions towards the end, or I'll pause and open the floor for audience to answer if you already have questions. The first and foremost, most important question for the 4 mutually exclusive modes is, how is the scenario best model? I found 3 different possible answers based on the existing Corim spec, which are shown up here. One is the Corim map.profile, wherein a single Corim, which may imply that we will need to have a single Corim for each mode, each of those 4 modes in my example. The next is the mid tag, which obviously means we are talking about co-mid now, not co-switch, which creates that difficulty as well if you have the mode associated with both commit and co-switch tags. But bear with me until I finish all the options. But commit tag itself has 2 sub options. One is tag att.tag ID, and then it has a class ID associated with the triples. So triples, reference triples, ref environment, which is an array, and then the class, which is a class ID. Each of these have their own advantages and disadvantages depending upon the level of granularity and the place where which you want to model these different modes. I have listed these options 1, 2, and 3, and the few of their pros and cons up here. My question to the audience is, are all these valid options? And if these are valid options, what are the scenarios in which each of these is the best option? And is there a 4th option, for example? I'll pause here to see if anybody has comments.
So I wanted to kind of understand, is it the same environment? Because effectively you mentioned the option 3 as a class ID. Is it the same environment that has these distinct states, which you mentioned, CC, non-CC? I'm presuming that, but I wanted to check with you before I conclude.
Correct. Yeah, when I was saying the set of possible measurement is same, that implies is the same environment.
Okay.
Yeah.
And you mentioned that the measured elements within the environment, the M keys, are also potentially the same, right?
Yes, correct.
Okay, so the other 4th option then could be you can have multiple reference triples within a commit, and each reference triple can possibly indicate one of the modes and its associated measurements corresponding to that mode. So that's option 4 in your.
Is that different from class option 3? I didn't entirely follow. You're saying even within the reference triple, like when you have a class ID, you say class ID reference triple number 1, 2, 3. You can specify several of them.
Basically, what you have done in option 2 is you have multiple commit tags. You have a list of commits within the Corim, right? But effectively, you are talking about the same environment with possible reference states. You can treat these modes as possible acceptable reference states. And within a single Corim, you can have n number of triples with the same environment as the subject and the measurements corresponding to these modes. is an acceptable way of representation as an option 4 here.
Okay. I'm still unclear though, what is the field that you would use to model? Is it something within the reference triples other than the class?
So the measurements, so you would have a reference value triple corresponding to each mode. And in that, if you want to have the specific name of that mode, you can potentially look at maybe there are in the measurement values map, you would have a version, or you have some kind of a text field to represent a particular measurement. In that you can stash the mode, and rest all stuff like digest and all that you can encode in there in the measurement values map back for that particular mode.
And I want to add something, Yogesh. Like the
Yeah.
class ID basically is is used to represent the target environment. Basically, what
Correct.
you're doing. Like it can be a mode. Like you can have a class ID mode, but like we mentioned, we had a discussion in another forum. You can have the same class ID into the reference triple value array, and the class ID value 1 means CC. Class ID value 2, and they could be all valid option, all valid state where the platform can be at.
I don't want to take it to this direction because ultimately it is the same environment, target environment that is being measured, right? So you would want to identify the environment uniquely with the class instance or group parameters, which is essentially the same for these 4 modes. So I would not want to model it like that, but I cannot stop others from having their opinion or way of abstracting it out. I see the Greg's hand up as well. So
I don't have an answer, but if I were thinking about this, it seems to me like I would want to be guided by what's the scenario, the Uber scenario or scenarios plural, that will make use of this mode, right? So for example, I imagine that you might have different endorsements based on different modes, right? You certainly don't want to, like, if you're not in CC mode, you probably don't want to release, your secrets into the device at that point. So that, to me, the question is posed as a data structure question, but I think the answer then becomes how do you use the data structures, and then that tells you kind of, what's most optimum, right? Because you could probably, as you point out, get away with putting it anywhere and making things work, but then how difficult are your scenarios going to be based on the choices?
So Greg, I have a follow-up to what you just mentioned. The endorsements, in my view, the certificate chain need not be different. So imagine there is one attester, like one component of the device, which is the attester, is responding to attestation queries in all the modes. Let's assume it's the root of trust processor in the device, and it is the first entity that boots. And so it boots and sits there. It has full access to the environment that is to be measured, but the environment is set up differently based on how many steps in the boot process have been performed or what else has happened. So it has visibility into everything. It can always report everything and will always report everything with its own certificate chain.
Yeah, I'm imagining there's a relying party that basically says, only release my secret into the attested environment if the mode is CC.
Exactly.
Right?
Exactly.
And so far, you're only talking about reference values. You're saying, reference values for any of these 4 modes is fine, but the decision made by the relying party is about an endorsement about these reference values.
Yeah, this is actually the subject of next slide a little bit. Let me just jump to this and try to answer that. So I have talked about reference values because the devices may not themselves have a separate evidence to report, which is called mode, right? From let's say in this example that I took of the root of trust processor, the mode may be made up of several different, say, registers. For example, some runtime state, some static state set up due to the contents of the firmware. And so it may be difficult for the tester to even know what these various modes are. So all it is doing is literally reading all these registers to respond, packaging them up and returning back. The verifier I'm expecting would be comparing, in my example, 4 distinct set of reference values, trying to find an exact match and say, oh, it matched the first set, it corresponds to CC.
But is there a policy which you need to understand that at this point in time, when the evidence is reported, the evidence should be in a particular mode?
It's not that evidence should be in a particular mode. It is more that if this evidence, imagine for sake of simplicity that there are 4 quorums in my example for the 4 modes. Okay. What the verifier would do, and you all can correct me if the expectation was different, but I think there is a difficulty and we'll walk through the verifier process in a moment as well. What the verifier would do is that it will first try to do a quorum lookup. All it got is a certificate chain from the device and a set of evidences our device claims. Now, all it is trying to do is figure out what's going on. Does anything match? First, it's going to look up the make and model of the device, sometimes serial number, but let's assume all devices are the same and serial is not relevant. So we'll focus on make and model. And then it will look at the certificate chain. That's all it has to look up the possible set of quorums before it has to peer deeper into the evidence itself to figure out which are the 4 quorums that should match, right? So all it can do is look at device make, model, and a tester ID from the certificate chain. It will end up with 4 quorums in my example. Now it's going to look at the evidences and compare with the 4 and see if any of those 4 match.
But I want to do something, Dawale, like the quorum, like I think we are confusing 2 different appraisal policies: appraisal policy for the verifier and appraisal policy for the relying party. The first one, you're just checking that whatever state your evidence in is an acceptable state. And you are saying that all confidential computing, non-confidential computing are all acceptable. Then the second part, it will be kind of like get an endorsement, like so basically the relying party will get the full, doesn't get a pass or fail from the verifier. The relying party get the story from the verifier. And then the relying party want to say, oh, I want to only accept this in confidential computing mode. So the verifier just say, this is in an acceptable state. The state is at is this. Then the relying party add a further policy to make this decision later on.
You're right. There's one subtlety which where you and I may differ. So what I was trying to get to was, once the verifier has done a match, and let's say did find that it is the first set that matches, and first set corresponds to CC because somebody encoded, like we discussed in the first slide, in the class ID, that this means CC. So the verifier would return CC, or the class ID in this case, to the relying party. So that relying party doesn't have to connect the dots and figure out a conceptual mode, right? It knows the mode from this class ID in this example, and then it makes the decision based on the class ID. So what I'm trying to get the verifier to do is return this logical piece of data called class ID or mode to the relying party. I don't know if you thought it the same way, but that is the one key piece of possible difference between us, which is, even though if the device has not returned the mode to the verifier is returning the mode to the relying party.
Yeah. I think Fabrizio summed up correctly that these are the 4 possible states. The verifier knows about the device. Device doesn't indicate that particular mode, but it can compare and reflect the mode to the relying party, and its relying party's policy whether to accept the device in that particular mode, or can do only certain set of actions based on what mode has been reported by the verifier.
And I think from the quorum perspective, there's 2 ways that mode can flow to the relying party. One is the quorum itself could have some additional endorsements that basically map these 4 different sets of reference values to an endorsement claim, essentially, or the class ID, could kind of be included in the attestation results, and the relying party could then, essentially determine the mode based on that flowed through class ID kind of thing. the way I think of and have been using COREM in the last year is there's the reference values, which are about establishing whether the measurements are authentic, but then when you need the endorsements part to give the semantic meaning for the authentic measurements to the downstream relying party. So I haven't done too much, but the little bit I've done so far is kind of, there are no scenarios that I'm working on that don't include endorsements, where all the verifier does is look at reference values and then kind of ship things along. I'm not saying they don't exist, but I'm just, in the way I've been using it so far, there's always some endorsements involved.
So, Greg, can you help me understand what you have in mind with respect to endorsements? Typically, when I think of endorsement, I think of the certificate chain, but it seems you may have
in COREM,
different.
right? COREM says if you have, so there's a first step of like matching reference values, and then once there's reference values that match, then you can additionally turn the crank applying endorsements that say, if you see reference values that match, if you see these reference values, these reference claims with these values, then you can add essentially another claim. I think it was endorsement claim, right? So you could say the set of reference values that basically establish this is a pre-boot, circumstance. You could have like a single claim name called, device mode. And you could say, okay, if I see the pre-boot measurements, the device mode claim endorsement is pre-boot. If I see the CC measurements, the device mode claim is, CC.
Yes.
And then the trust decision is, so the endorsements are kind of tuned for the trust decisions by the relying party. So what I'm imagining here is the relying party is just simply, it's a simple scenario in my mind, just wants to release a secret only if the device mode is CC. So that could, would just look at that one claim and would never look at reference values.
Okay. Now, Greg, that's actually how I thought of what your second option was. So can you help me understand the difference between the two options one more time?
Oh, I would, and I'm not familiar with the details of the first one. I'm just, when you talked about, everything I've done essentially has one class ID so far.
Okay.
So when you're talking about like multiple class IDs and each class ID like being tied to like, this is the class ID for the CC reference values, this is the class ID for the pre-boot. I was thinking that magically, if that gets down to the relying party and attestation results, they could do their policy based on, essentially is class ID the CC one or is it the pre-boot one? That to me seems a little bit obtuse because it's, the endorsement is, from a COREM perspective, in my mind, is specifically trying to provide that the semantic kind of information we're talking about here. The manufacturer basically, or the device manufacturer says, you don't have to think about all the details behind it. Semantically, they're saying device mode is, CC. So.
Understood. Yes. Perhaps the way I mentioned it, it created that confusion. I took class ID as an example. As you know, I have three different options. What I was implying was, whichever of these three is chosen, there would be a logical name like CC in the claim set, the attestation results claim set.
Yeah. So from a verifier, I work on a verifier, and from a verifier's perspective, the beauty of COREM is I don't have to put any code in. I just do what the COREM tells me. So if you basically define the claim, the claim name as device mode and the different values in COREM endorsements, I don't write any code in my verifier other than understand how to process COREM reference values and COREM endorsements. And I have no specific knowledge about, NVIDIA has a notion of something called device mode, and I just run my engine, right? And it swallows the code. That's the whole kind of purpose of COREM, is to make the verifier more metadata driven and not having to understand and be tethered to specific, attestation evidence formats and so on.
And for that, you need a conditional endorsement where you say that when I have this environment and this reference value, then call this endorsement as mode 0. And that's perfectly fits the use case because this is not, mode is not something which is coming from the evidence. So cannot be compared it with reference value. Mode is an additional endorsement, which is related to the verifier, from the verifier to the relying party. My apologies. Yeah.
And so, Yogesh, since I'm not very familiar with how the verifier builds its claim set, or at least how it would build independently, would each of those three options work? I'm not entirely clear.
I think I think none of these three options actually is the way we are proposing here actually.
I see. Okay.
Yeah.
Would you mind then sending that option perhaps through the chat?
Sure. I can write an email to you, Dhaval.
Thank you,
copy. Yeah.
All right. So I think we discussed this slide. Go ahead.
I have one
Usama
question.
Yeah.
So I'm independent of the formats that you are discussing with Yogesh and so on. So I have a different question. Like I'm trying to get my head around overall architecture that we are talking about here. And there I will try to sketch what it's in my mind from all of this discussion, and correct me if I'm wrong. So what you are trying to do is basically you have a CPU, or the case I'm imagining is that you have a CPU, right? Which is attached to, and a GPU is attached to it, right? And the thing that we are talking about, the four modes, maybe makes the most sense that the GPU is in one of these four modes. And it was not particularly clear to me whether when you were, for one of the discussions, you were saying attester, it was not completely clear to me whether attester to you means the GPU, or it means CPU plus GPU, or just the CPU. So I'm trying to kind of sketch that in my mind. So that attester to you mean both. Is it correct?
No, attester to me means typically that one specific device, but in particular, it may even be a subsection of the device. A given device can have multiple attesters, theoretically speaking.
Right.
It doesn't matter, Usama, whether he's talking about a particular piece of the whole attestation story, or is it the whole attestation?
Yeah, Yogesh, from your perspective, it doesn't matter, but from my perspective, it does matter, right? So I'm going towards something completely different. As I said in the beginning, that I'm not talking about formats at all. So if you have any question, you can go ahead, Yogesh. So I want to talk about something completely different.
Okay, go ahead.
Maybe before we go on to something completely different, I'm just curious from a RIM perspective, is there actually like a simplifying choice here that, at least for confidential computing, there is only one valid mode. So you would only publish one RIM. The device could, certainly be in those other three modes, but those aren't relevant, at least from a confidential computing perspective.
Right. Then the relevance from confidential compute perspective would be from the verifier looking up the quorum. So the whole purpose of all these questions is, how does the verifier look up the quorum and produce that claim in the attestation results?
Sure, but I'm saying that the verifier would just go get the NVIDIA RIM for the, for the, I don't know, Hopper 100 card. And if the device attested back with a value that was in one of the other three modes, then that wouldn't match the single RIM.
Yeah. Are there remote attestation scenarios that that flow through the non-CC mode of the device?
Yes,
is I think the question. If there are, then you need. I think you need the co-RIM and the reference values. If there aren't, then no.
Exactly. The very purpose of mentioning those four modes are there are four distinct sets of reference values to compare to. It's not
what
just
are the
one
consumers
set.
What are the consumers of the non-CC modes? Because I get to think about only confidential computing. I can imagine there's things that aren't confidential computing, but it's hard for me.
Sure. So let's go back and talk about pre-boot. That is definitely one scenario. So again, pre-boot is a case where the device firmware is booted. You possibly don't have SSD, so the driver may not have booted. This is a classic case for platform attestation. Imagine that you are a cloud service provider. Forget CC, it's traditional compute. You are trying to ensure that you have the device in a clean state before you assign to next tenant. There is a whole life cycle. There are many other states. I'm going to just mentioning one state. So how do you ensure that device is in a good state? You run attestation on it. And that's when you assign to the tenant. Tenant comes with their own SSD, load up the drivers and do the rest. So that's the pre-boot mode. And there is definitely this use case exists as of today.
Okay. Thank you.
And then you can imagine when the driver boots up, there's a CC mode, there's a non-CC mode. In CC mode, the bar is higher, but there could also be the traditional compute, which is a case of trust but verify, meaning the platform provider has provided me a clean slate. I have an SSD, which I expect to be in good state, but how about I verify everything before I run everything, before I run my workload? So that would be the non-CC driver mode. So now the driver has CC mode and non-CC mode. I just added more states in my slide just to highlight the possibilities of what can happen to ensure that we are not intently looking at CC versus non-CC as the only two possibilities and design quorum in a manner or verified in a manner that we are tied to just these two possibilities.
Got it.
Okay, so back to my question. So about so as I said, it's different from the scope that this discussion was. So it's nothing about the formats at all. I'm worried about something more high level than that, which is namely that. So that's what I was trying to sketch. Let me sketch again now, because there was just to go back to that scenario. So there is a CPU, right? Let's say that's Intel TDX, and there is a GPU, NVIDIA H100, 200, whatever is attached to it, right? Now, what you said was that when you were mentioning a tester, you are kind of thinking only the GPU perspective, not the Intel TDX, what's happening there and so on. You don't care. So you are, from your perspective, you are worried only about the GPU in this case. Is this correct so far?
Not entirely, Mohammed. What I was trying to say was that the device itself does not really matter to me for this particular discussion. You can say I'm representing CPU, GPU, DPU, any device you pick for this discussion.
Okay, that's fine. So now my kind of thought is, or my worry is that if the GPU, let's say, keeping the same scenario, TDX plus NVIDIA GPUs, so the GPU, I'm taking the device now as the GPU, NVIDIA H100, 200, whatever it is. So this keeps on changing its state. You said they are mutually exclusive. Let's assume that it was in CC mode. Attestation evidence was generated and sent over to the verifier. Verifier verified it. The relying party also verified it, sent it over the secrets. And all of a sudden now the device meaning now the NVIDIA H100 has now moved from CC state to the non-CC state. And the relying party has already sent over its secret. So here is my worry, independent of whatever format, whatever 1, 2, 3 quorum commit, whatever you choose. So this is a bigger problem than that, which is at a higher level of abstraction, independent of the formats. So this is what I'm trying to understand. Can you help me clarify this?
Yes, that is the classic problem, as I'm sure you already know, with attestation, which is attestation is a detection mechanism, not prevention mechanism. So the way, in my view, we are obviously changing topics, but I'm just going to express my view. The way things should work, if we are expecting attestation to not happen so frequently that your security assumptions are violated, is that there should be device configuration registers that are used to lock the device into that particular state. And one of those claims that device should return back as a part of its response, attestation response, is the state of that lock. And the lock could be released later, but the lock should be returned back and verified and it would be part of, in this example, the reference values. One of them would say the lock value is, say, 1. And that indicates that in CC mode, the verifier is going to ensure when it is comparing the reference values that the lock value is 1. It need not be 1 for any of the other 3 modes, for example. And that way you would get the assurance that if you did that attestation, it wouldn't change. We all understand there can be runtime compromises. We are measuring the state on the flashes. So we are still not in the perfect state. Things can still change. But obviously we know that at least to a first order, that the things that we measured, those are not going to be changing if we use a lock.
But that lock itself is like, I get your high level idea, but my next worry now is the lock is itself being sent over the lock bit or lock byte or whatever that is. That's also being sent over from the GPU. You only know that at this point in time, the device lock was 1, but what guarantees me as a relying party if I am giving you over the secret and after getting the secret, you change over the lock?
Yeah,
so
good question.
And
Let
you
me
also
clarify.
Sure.
Yeah, so I did not cover one portion of it. There is a life cycle associated with
Excuse me,
the
Dual,
lock.
can I just jump in for a second? There's just a time check. We've got 14 minutes left, and this topic's not on. I don't think this topic's on the list. So I guess just be aware of the remaining time, to use optimally for what you want to cover in this meeting. We do have additional content for the next couple meetings scheduled, so chances are low, unless you can twist Gary's arm, that you'll get more time in a couple weeks.
All right. Okay. Yes. So Mohammed, I'll just answer that quickly, and perhaps we can schedule any further more follow-ups later. Is that okay with you?
Yeah, sure. That's fine.
So,
or if you want to proceed, you can also skip this.
Sure,
That's fine for me.
Yeah, let me just finish that at least one response. So my expectation with the lock is that there is an assumed life cycle associated with the lock. Meaning if I lock it, then until you issue a certain reset, say for example, PFFLR in this case, and the lock would persist until then. And that is backed by hardware guarantees. Now that you would have to know as a part of the design of the device. It's not something that can be encoded, or at least I do not know, at least as of today, a method to encode the life cycle of any evidence that has been reported or claims that has been made by the device. With that, let's keep moving. So second scenario to consider, which is different claims for user versus owner. Somewhat hypothetical, but I think can exist. So imagine again the case of a cloud service provider as the owner and user as the tenant. The cloud service provider may have its own set of policies, and the device user or the tenant may have no use for looking at those policies. Likewise, the device user or the tenant may have set up some state, like booted in my example, some software using the SSD, and the cloud service provider was only providing bare metal services to the tenant, in which case returning those measurements back to the device owner makes little sense. Again, even if you look at a particular mode, let's say it's non-CC mode for sake of example, when the device owner or device user are both querying the same device, same attester for evidences, the device may choose to produce different set of evidences to the two different requesters. That would again lead to a modeling difficulty in the quorum. It's in the exact same state, but two different set of evidences. Perhaps it could be modeled using what Yogesh is going to send to me, and I'll revisit that with Yogesh later. But I just wanted to pose the question in here that the device can be in the exact same state, but there are two different views of the evidences. We talked about pre-boot, so in the interest of time, I'll skip it. The only additional note I will make here, even previously I'd said the set of reference values, or sorry, set of measurements available to the root of trust in my example was the same, and hence the list of reference values were the same. But there could also be a scenario where, let's say in a pre-boot world, not enough of the device has booted. So it's simply not possible to read those additional registers. And the last one is that of extending, just as in PCR, I talked about the journey toward the beginning of this of my presentation. So I'll skip this in the interest of time. And I'll just pause here to see if there is any further discussion we want to have on the modeling, mostly from the perspective of quorum. And then if we come up with, hey, this is the recommended method for scenario 1, 2, 3, 4, or just one that covers all of them, then do we want to write these examples in the RFC to ensure consistency? As you can imagine, I've written 3 options. Yogesh has a 4th one. Clearly, different people can come up with different options to ensure consistency across the industry. Wouldn't it be nice to ensure that everybody uses the same method in their quorum for reporting? I'll pause here to see if there are follow-up comments.
We did discuss this in our quorum meetings about how to help the community. Well, RFC, we believe that RFC is not the right place, but we should have an implementation guidance document which sits next to quorum, which helps implementation community to understand how you can utilize the quorum in the best possible way. And there we can suggest some of the examples as recommendations, because we cannot have a normative text to say that, no, you have to use it this way only. So that's it. Yeah.
Implementation guidance, perfect. I wasn't aware that there was something like that planned. Thank you. And Yogesh, just for my understanding, is there something already in place, or is it intended to be started?
I would request, I mean, we haven't started anything yet because of lack of time and lack of resources, but we would very welcome if, I'm not talking about you as a person, but as an organization, if NVIDIA can stand up and start preparing that document, we will be very willing to help them mentor and come up with a nice document.
Okay. If you have any template, as you know, I'm already trying to do some of this. So if there's a template you would want me to follow, I'm happy to start the document and we can go from there.
Okay, awesome. Brilliant. I will share the requirements later. Yeah.
Thank you. All right, this is the second topic. Sorry, actually, you know what? I'm going to skip this one.
Are we not going through the question queue, or do you need to go through? Or did you want to go through the other topics in the remaining time?
Yeah, I just wanted to cover the remaining topics. If time permits, I'll come back to these 2 slides.
Oh, okay. So you want me to hold off on my question then?
Your question was related to these 2 slides. Sorry, I didn't get that.
No, it was related to the previous. So.
Oh, okay. Got it. Yes, please go ahead with your question. I'm sorry.
Yeah. So first off, I don't believe the 4 scenarios that you outlined are mutually exclusive, but I'll leave that aside. I think it's going to be a long discussion. Getting back to a specific example of non-overlapping claims. If we go with the pre-boot scenario, where you're mainly getting what I would consider a set of platform claims that can be verified against a quorum. I believe that a confidential VM would also be interested in platform claims as well, in addition to claims that are related to its own integrity. Therefore, I'm wondering why a quorum has to be defined that differentiates between the 2 modes. If you're in a pre-boot mode, you can define a quorum with the necessary platform claims and potentially VM claims. The verifier would just ignore the VM claims because it's not getting anything in the attestation report. But if there's a guest VM, it would actually consume the platform claims in addition to claims related to its own integrity, and both can be verified against the same quorum. So I'm wondering why you need to actually, if I understood your presentation correctly, you were saying that that in those cases you would actually want to define 2 separate quorums, which I I'm thinking it's not necessary, in those scenarios.
To be clear, I wasn't necessarily implying two separate quorums. Those three options that I gave were part of the same quorum. Well, actually, the first option would have implied multiple quorums, but second and third does not imply different quorums, but they imply different sections of the quorum. And if you're asking why not put them all in the same section, well, the reason is that I'm not aware of any Boolean in the CDDL which says ignore this particular reference value if you're in that mode. First of all, MAD mode itself is not returned, right? So verifier has to match. It is inferring the mode. So if I gave a set of garbage reference values or put in some garbage values into the quorum, it would just lead to a failure. So I cannot put everything in every possible mode.
Well, okay, first off, you can define environments. You can define even multiple environments within the same quorum. So that's it. The second thing is the concise the commit and concise evidence mapping is already exists in the spec. So if we've already kind of established on this call that you've established 4 modes, several participants in the call don't think those 4 modes are mutually exclusive, but I mean you can actually make the mode itself measurable and report it that way if that's the desire, right? It can be reported as concise evidence and match against an appropriate commit. And the verifier can process according to that. If it sees a mode that's actually provided as reportable evidence, it would actually have a different appraisal policy against the rest of the claims that it receives. So it doesn't seem like CORIM is lacking in definition to meet your requirements from that perspective. You have 4 scenarios. You can define a 2-bit measurable value and send that in the attestation report. Yeah.
But in my example, the device doesn't necessarily know which mode it is in.
Exactly.
The mode is a conceptual value for
it's an endorsement. It's not in evidence. It is not in the reference value.
Well,
that's what that's why I came to know from Dhaval. It is an endorsement.
Well, that's a decision, right? I mean, it doesn't have to be. I mean, if we're talking about, for instance, boot stages, which is what you've essentially defined it, or operational stages. Surely there's a trusted entity on the device that knows what operational state they can provide evidence of the operational stage of the device. So,
you could do it that way as well. I think yes. Yeah.
Okay. Anyway, I just wanted to make that point. It wasn't really a question, but we can move on. I know you got other material.
Yeah, when we get more time for us, we can continue to discuss. Looks like we have only a couple of minutes remaining. So let me just quickly mention the topics. I think this is an important topic which I wanted to mention, which is that of revocation. Currently, there are a few widgets within the quorum based on my.quorum, which get closer to how a certificate operates. One is the concept of validity period, which is there in the quorum, so no issues with that. Then there is revocation, which is even if it is valid, you want to replace it. Couple of scenarios that can happen with quorums is there is superseding case. For example, somebody issued a quorum which had only 5 reference values in it, device reported 10, maybe 7 were relevant for comparison, but they put in only 5. Now they want to correct it, add the remainder 2. The second is, well, there was genuine mistake. Mistakes can happen, not that people intend to, but can happen, and it was signed and published. And this is not entirely the case of a certificate revocation because the private key itself was not compromised. So while using a certificate, meaning if let's say I had 1 certificate for every quorum I issued, I can go revoke the certificate. It doesn't feel architecturally the right concept to go revoke the quorum. So the question I want to pose here is quorum development in this area already done? As in, are there more extensions to make it look more like, are there more extensions planned to make it look more like certificate revocation, in particular, the concept of a CRL or an OCSP responder? So somebody could go and check, is this quorum data still applicable and not revoked? I'll just pause here. I didn't mean to cover the entire slide since we didn't have enough time.
Can't you functionally get the same end result by putting a validity time equivalent to the required frequency to update your OCSP response or your CRL response?
No, that would not be the case, because when you are issuing, in general, if I believe truly that I'm signing the right data, even though I may have made a mistake, then conceptually the data is valid.
No,
has an
I
infinite
get the
validity.
conceptual, but even
Yeah.
in the design where you use OCSP or CRL to basically do this, you do have to make a decision when you're issuing the CRL or issuing the OCSP, what expiry you put on that. And that ultimately controls the freshness by which downstream they're going to get an update, right? And so I'm saying you can force, you can mechanically, it has implications design-wise and operationally and so on, but I think that like if overall, I think from the scenario perspective, for let's just say number 2, right? Overall, it's like what's in place that forces an update to someone making a decision within X time. If you're using OCSP, you put X time in the OCSP response. If you're using CRLs, you put in the CRL response. If you're just using vanilla co-RIM, you have to put that in the RIM validity, time. And the end result is the party making a decision will be forced to do a refresh through some technology to get an up-to-date answer.
Understood. Now I'm getting, I understand where you're heading. The one difference difference that I would say compared to that scenario is that in OCSP, typically the response is not valid for very long, right? So what that would create using the usage of validity to simulate revocation would force very short validity on the core, like a day, or less than a day, which is going to be very painful because we are talking about signing data using private keys, which you want.
Well, no matter what, the requirements in my head are the same. If you basically have a requirement for a timeliness for the data, and you have a requirement that the data is signed, so you may push it around different places. You push it to the CA signing, a CRLs or OCSP, or you push it to the system that generates the co-RIM, but somebody somewhere has to sign a statement every n days, hours, months, whatever. I think from my perspective, the tooling is much more mature out there to run kind of this stuff for certificate chains. But I agree with you; it's very obtuse and hidden to address this requirement for co-RIM in the certificate chain behind the signed co-RIM. I don't have a good answer. I know I'm struggling on my side, and I don't know where it's going to land.
Okay. Yeah, and I would also urge you to think of air-gapped environments. Those are also use cases. So far, the general expectation is that people just turn off OCSP checks in that, not necessarily the validity checks. And so we try to use validity to replace the OCSP check. It can create some additional difficulties.
I think you do have the questions of is there value in considering additional schema in co-RIM to facilitate this? I think it's a good question, and maybe it's just a stepping stone might be, does the co-RIM have maybe it's already there, I just don't remember it, but some sort of mechanism to define, like if you just land with if you have a co-RIM, can you from the co-RIM figure out where to go get an updated one, right? Or is it in there, right? I don't even
exactly.
That might go hand in hand with the RIM validity or something. So
perhaps just like it has a tagler replaces, where the new one specifies which old one it replaces. If the current one says, go look here to check if there is any replacement or any updates about me, that would be nice. But
there is a way you can point your new co-RIM to the old co-RIM, and that you can use.
That's the replaces thing, right, Yogesh?
I believe so. I need to check,
Yeah,
double check. I
yeah,
was checking that, but there is a way to
yeah,
point your new quorum
yeah.
from the old quorum. So
Yeah, correct. So the concept is slightly different, Yogesh. First of all, the current one, not the new one, needs to be checked without necessarily an existence of a new one. And it's also not saying go look at another quorum. It's saying go talk to somebody else to find out my validity, or rather whether I'm still relevant.
Hey, we're 5 minutes over, so I think we need to call time. I see Gary's still here. I suspect there's this
Okay.
conversation material hasn't been completed. From your perspective, Dual, would you be interested in continuing the conversation at a future date?
Yeah, let's do this. I'll Fabrizio unfortunately had to drop. I'll talk to him about maybe seeing if we can compress to a half hour and we give another 30 minutes to double for the next meeting. Because I believe we'll still be proceeding IETF at that time. And so, I mean, if there are things that need to come in for, related to inputs to quorum, it would be good to get it on the table before the next meeting.
Thank you so much. Thank you so much. I really appreciate it.
Okay, so let's confirm that, and I'll talk to Fabrizio and we'll make it to 30 minutes. Okay.
I think the next meeting, CCC, this topic is on 4th of November, which is right inside the IETF, if I'm not mistaken.
Oh, is that the case? Yeah, but we can still hold it, right? I don't think it overlaps the RATS meetings. Is that correct?
This is in the Western, right? In the Canada, right?
Yeah, yeah.
But we also have the SEAT working group, which is for attested
okay.
TLS. I'm not sure
Okay.
that's also on Tuesday. I have to check what time it would be for this meeting, if there is an overlap or so. But that would be tricky. Typically, in the IETF meeting week, we cancel the SIG meetings.
Yeah, that's what I was.
Yeah. Okay. Okay, then I guess we cancel the SIG meeting. We'll have to take this up in a meeting afterwards then, unless we want to hold a special meeting next week.
RATS is certainly not there on Thursday, is there on Thursday and Friday, so we are clear from the RATS perspective. But there may be others in this group who might wanted to attend other presentations apart from RATS. They may have a conflict. That needs to be checked before we before we make a decision whether we want to hold this after 2 weeks from now.
All right, so I think we have three fuzzy things going on. One is, I think the topic for 2 weeks out, probably the OCSP entity attestation token profile, Gary and friends, that's probably not happening because you're not available. The other is that a lot of people on this call may not be available in 2 weeks. And the third is, when does Dual get a chance to finish this discussion?
So just a very important thing to mention. So the SEAT meeting, SEAT working group meeting is exactly overlapping with this. So Giri, we need you there. So we need you there. So
okay. So I think you're going to have to cancel the next meeting. And what we'll do is, unless you want to schedule a special meeting next week, we'll have to resume the week after the next meeting.
I suspect special meetings are for this group isn't going to fly. So do we want to cancel 2 weeks from now, or do we want to? Would it make any sense if Dual was available to continue finish up this topic in 2 weeks?
Well, I think Osama just mentioned a lot of us will be in the SEAT meeting.
So Greg, just to recap, so the attested TLS working group that was newly formed will have a complete overlap with this. I will encourage everyone on the call to at least join remotely, because that's what we have struggled a lot for this, and we need your feedback, all of you. I would request to cancel that meeting. Of course, I'm looking very much to the talk of Giri, as well as following up on the questions that were remaining from my side for the wall as well. So that would be very interesting, but that has unfortunately complete overlap for the meeting we have for SEAT.
Okay. So let's coordinate whether we cancel in 2 weeks and how to rejigger who's talking about what in the Slack or the list in the next handful of days. Sound good?
Okay.
Yeah, sounds good.
Thanks, everybody.
Thank
All
you.
right, thanks.
Okay, bye.
Thank you. Bye.
Thank you. Bye.